Hey kids, hope you're having a fabulous day. I just wanted to show you something quick before we start our new lesson. So I'm just gonna show you in case you haven't, but oh boy, let me decide. Okay, this one works. So if this is what your calendar looks like, this is I think for period 4, you'll notice like today, this is our lesson right here, the notes, the video that you will be able to click on and then recording it. And then if you haven't been coming to our Zoom meeting, I know I told you it's not required because it's not, but I have been just doing the homework with the kids that are on there. And all you have to do is if you want to come, you don't even have to talk to me, but if you just want to come and do the work with us, you just click this link here and it'll bring you right to the Zoom meeting. And then, I don't know, it's just a way for you to see how problems are done in real time instead of just watching this video where you can't stop and ask me questions. But I know a lot of you don't even do the assignment on this day. You do it when you have time, and I get that. That's why I'm not requiring the Zoom meetings. I just want you to know that is always an option for you if you wanted to do work with me in real time. Or, like always, you can always email me and we can Zoom at a different time that works for you or whatever the case is. And then once I'm done with the Zoom meeting, I attach a doc here of the problems we went over, just for those who need to see how it's worked out as well. Okay, that's all I wanted to share real quick before we just do the normal procedure of our notes here. Get this back up. Okay, we are splitting up our next lesson into 2 days, or just 2 different days, because it's just kind of a lot to do in one day. And the first day is just on composite figures. To be honest, we probably don't even need to do a lesson on it because I think you're smart enough to figure out on your own. But I think the hardest part is, well, do I know what a composite figure is? You do. I just don't know if you've ever given it a title before. And all a composite figure is a figure that can be broken into pieces. So it's just going to be some random shape that we probably don't even have a name for, and you're going to break it up into regions or pieces that you do know how to find the area of, like the ones we've learned: parallelogram, rectangle, trapezoids, circles, triangles, rhombus, whatever. As long as you can find the area of it, it works for me. That being said, there will be multiple ways to do these problems. I'm just going to show you how my brain thinks of them, but you do you. You know, that works for me because at the end of the day, this is for you, not for me. Yeah, so our process to find the area of this is to divide it into regions and then add up those areas of those different regions we found. So if you want to jot down a little definition for yourself of a composite figure and then the process to find it, again, you're just taking a shape, dividing it into parts that we know how to find the area of, and then adding them together. So we're going to do a few of those together before I set you free, okay? Here we are. It says, find the area of the figure. So like I said before, there will be multiple ways for you to do these problems, right? We all visualize things differently, especially me, who, I don't know, I'm not the most artistic person. So I always try to do what's going to be easiest for me. So for me, I notice that I have an 8 here and a 12 here, right? So if I were to go down like this with this side, I would now have a rectangle and then a trapezoid. And good news, guys, is you know how to find the area of both of these things. So if I want to start with the rectangle, I think it helps if you label it. You do you. Here we go. So if I wanted to find the area of this rectangle here, folks, look. My dimensions are 12 by 8. So 8 times 12, total of 96. So now we just found the area of this guy. And now we have left over is this trapezoid. So if I were to turn it like this, do you guys agree that this would be a trapezoid? Here's one base and here's my other base. So what we're missing is this base down here, but good news, this length right here is the same as this guy right here. So that's 12. But now my question is, what is our height? What is this guy here? So I know the whole bottom side of this shape, of this composite figure, is 15. And up to here is 8. So what's left over of my 15? Well, 15 minus 8 is 7. So if I want to flip this back around here, there we go. So if I want to find the area of the trapezoid, let's fill in our formula, half our height with our bases added together. So I'm going to have half. We said our height was 7. And then our bases we said were 5 and 12. And now we just simplify. So half of 7 is 3.5. 5 plus 12 is 17. 3.5 times 17 is 59.5. And then to find the area of this whole thing, I'm going to take my 96, add to my 59.5. So I'm going to do total 96 plus 59.5. Crunch that out and I get 155.5 units, inches squared. That's it, folks. So again, you're going to be given some wonky, weird shape that we wouldn't normally be able to find the area of just on its own. Break it up into pieces that we know how to find the area of, like a rectangle and a trapezoid. Add our areas together to get the total. Perfect. Let's cruise right along to our next problem here. Find the area of the figure. So, this one's a little more interesting. I see in my brain, I see a trapezoid here and a semicircle, right? The problem with my semicircle is I don't know what my radius or diameter is here, so that's not helpful. Similarly, my trapezoid, we don't know our height. The good news is, if we find it for one, it's the same in both. So our job is to find this height of our trapezoid. Okay, so it's kind of like the last problem. I'm looking for this height. I have 15 over here, and I notice that this is a right triangle, so now we can use our favorite theorem, right? Pythagorean theorem. But I'm missing this bottom side right here. What's that bottom length? Well, if we notice, up here is 22, and this whole bottom's 31. So 31 minus 22, that means this little guy right there is 9. So now we can do the Pythagorean theorem to find our height. So I'm going to have, let's see here, h squared plus 9 squared equals 15 squared. H squared is just going to be h. 9 squared is 81. 15 squared is 225. Subtract over that 81 and we find that 225 minus 81 is 144. Good news, we're getting a whole number, aren't we, folks? Because the square root of 144 is 12. So we just found our height to be 12. And now we are in business to figure out the area of this whole guy, okay? I'm going to shimmy this up just a tish. So I'm going to start with my trapezoid. So half height, bases added together. Okay, half, we just found our height to be 12. Our top base is 22. Our bottom base is 31. Half of 12 is 6. 22 plus 31 would be what? 53? 6 times 53, 318. That's wonderful. And then we have a half circle, semicircle. So let's first remember the area of a circle. The formula is pi r squared. And then since I want half of that, I'm going to take it times a half, or divide by 2 in the end, however you want to do it, okay? So what is my radius? What would this guy be right here? Well, I know my whole diameter is the same as my height. It's 12, so my radius is just 6. So now plugging in, I'm going to have half times pi times 6 squared. 6 squared is 36 pi. Half of 36 is 18 pi. Now if we crunch that out, 18 times pi, or 3.14, approximately 56.54. If we go to 2 decimal places, it will be 55 if we went to 2 decimal places. And now, if we add our totals together, we can figure out the area of this figure. So 318 plus 56.55, 374.55 centimeters squared. Good work. How do we feel? Are we loving this, right? It's just like all the lessons we had, the first 3 lessons put into one. Don't you love when we don't really have to learn new things, but we can just do different things with it? Because I do. I do. Okay, here's another one just to see something different. Again, there is more than one way to solve this problem. I see, in my brain, I'm thinking I have a rectangle, and then I can subtract away the area of this triangle. So let's start by the easy one, right? The easy one would be the rectangle, finding the area of our rectangle. So my dimensions of my rectangle are 5 and 6, so 5 times 6, total of 30, easy peasy. Triangle. So our problem with our triangle is what's our base, what's our height, right? Like we assume that's a right angle. Do we know that? No, we don't know that. So that's a bummer. But I know that my base right here is 6 because it's the same as my rectangle, so that's a 6. But we do know that this is an isosceles triangle, right? Because I have congruent legs here. And if I were to draw in my height by a property of an isosceles triangle, it would just bisect my base. So then I would know that this guy right here would be 3, and this guy here is 3. And now we can find our height, because we have a right triangle right there. So to find our height, we can do our favorite theorem, the Pythagorean theorem. So 3 squared plus h squared equals 4 squared. 3 squared is 9. We don't know what h squared is, and h squared would, 4 squared is 16. Subtract over our 9, and we're going to get 7. Just to make sure I did the math right earlier, the square root of 7 is about 2.6. 2.6, does that work for you guys? 2.6. So now my height is 2.6, so now we can find the area of that triangle. So half base times height. Our base we said was 6. We just found our height of 2.6. Half of 6 is 3. 3 times 2.6 is 7.9. Oops, sorry folks. There we go. Now our total area, because remember we're always looking for that shaded part, right? That's what we're looking for. So I'm actually going to take 30, and this time we're not going to add, we're going to subtract. So 30 minus 7.9 is 22.1 meters squared. Beautiful. All right, one more, and then I will not bother you via computer screen if you're with me so far. Okay, our last one here says find the area of the figure. This one's kind of nice because it kind of breaks it up into different shapes for us. In my notes, I see that I did it having a whole circle, right? So this is half a circle and that's a half circle. If I put those two halves together, it makes a whole circle. Then we have a rectangle and a triangle, or look, we have a trapezoid and two half circles. So we have, multiple ways to do it. Why don't we just do the trapezoid and circle, because it's just one less step, right? So let's start with, should we do the circle? What do you feel about that? Let's start with the circle. Find the area of the circle, right? So our formula, pi r squared. What is my radius? So if this whole thing is 16, my radius would be 8. So pi 8 squared. 8 squared is 64 times pi. Should we have just a tish? All right, 64 pi is approximately 201 point, we'll just go 0.1. We'll round up to just one decimal place. Now, let's look at that trapezoid. Again, remember there are more than one way to solve these problems, but I just noticed I can do it in 2 steps instead of 3. Our formula, half our height with our bases added together, half. Okay, so I'm gonna rotate this real quick just so we can maybe see it a little bit better. You guys see our trapezoid? There it is. Here's my height. This is one base right here, which is 16, and my other base would be 15 and 16, which is 31. All right, come back this way. So half our height we said was 32. Our base 1 is 16. Our base 2 is 31. Half of 32 is 16. 31 plus 16 is 47. 16 times 47, 752. Now if we add our total areas together, 201.1 plus 752, we should get 953.1 feet squared. Okay, that's it, folks. I hope you made it to this point in the video. Again, if you just want to hang out in our Zoom calls and just visit with people or see their face while we work on our math together, I really encourage you to do that. Again, not required, but it is just nice to see your faces because it's been so long. You have a super rest of your day, whatever part of it you have left, and I will hopefully see you soon.